In this video, we will discuss some questions from the practice exam 1, section 3 without calculators. And the questions that I plan to discuss in this video is on basically primarily on solving equations, right? So, as you know, the um, SAT exam has several, always they will have some questions on solving equations. So in this video I will just start with the 11th question, which is an MCQ question. Okay, so let's see. So we have b equals 2.35 plus 2.25x, c equals 1.75 plus 0.40x. So these equations represent the price of beef and chicken, right? So x is the number of weeks after July 1st. So x is some time variable, and b and c give you the price of beef and chicken maybe in the market or something like that. So they're asking what was the price per pound of beef when it was equal to the price per pound of chicken, right? So they want you to find the price per pound of beef, which is the beef over here, when they were equal, right? The chicken price and the beef price were equal. Okay, so this is basically solving an equation. So the key part is beef, so it was equal to the price of chicken, right? So meaning that these two prices should be equal, right? So what is this? B equals C, which means that 2.35 plus point, let me just write it here, 2.35 plus 0.25x plus, sorry, that should be equal. So C is 1.75 plus 0.40x. So in an equation, what you're supposed to do is basically you're supposed to isolate the x terms onto one side. You're going to isolate x onto one side. Okay, so we have x terms on both sides. What I would do is first, so I would like to bring the x terms over here, all the x terms onto the left side. So to do that, I will just subtract 0.40x so that I can just cancel this out, and then 0.40x. So we have 2.35 and 0.25x minus 0.40. So I'll just work out this arithmetic here. It's not that hard. So what you basically do is you subtract 0, 0.25, and it turns out this is going to be 0.15. But this is, the larger value is negative, right? So you end up having negative 0.15x, right? Okay, so 0.40x, and this cancels out. So that's the whole purpose of subtracting it by this value, and we have 1.75. Okay, we have x on the left side, but we still have another term on the left side. So we need to get rid of that. I subtract both sides by 2.35 minus 2.35. So this and this cancels out. So we have negative 0.15x equals, so you need to subtract this, so we get 2.35, so this is minus 1.75. So if you do the computations, you get 0.6 point, right? So you can do the computations, and negative 0.60. All right, so you have this x and a number attached to it, which is multiplied by this number. So you divide both sides by 0.15, or rather you can divide it by negative, because this is a negative value, right? All right, so this becomes x. So because these two cancel out when you divide each other, but you then have negative 0.60, negative 0.15. Okay, seeing this, students sometimes freak out with the negatives, the decimals and all that, decimal points and all that. So it's not that hard to deal with this. So you have a negative value divided by a negative value. So remember that when you divide, when you multiply two negative values, you get a positive value. When you multiply, when you divide a negative value by a negative value, you get a positive value. So these negatives cancel out. So you get this. It's the same thing, right? Okay. Okay. Now how do we deal with these decimal points? So you see that. So I mean, when you have something like this, what I would always recommend is too easy to see is that let's just move this decimal point to a place that we are comfortable with. If you just keep the decimal point after the 60, that would be just 60, right? Okay, 60. So I'm just going to move this over here, and it's going to end up after the 0. But we can't just do it for 60. We need to do the same thing. So we moved this decimal point to jump 2 times, right? So we'll have to do 2 times on this side, on the bottom side as well, on the denominator. So we do that 2 times. We end up having 15, right? So it's just like saying 60.0 and 15.0, which is exactly 60 and 15, right? Okay. So now I think this is easy. 60 over 15 is just 4, right? So your x is 4, right? So we'll do a few examples of this type after this question so that you can be comfortable with this. All right. Now they want you to find not x. So be careful. What was the price per pound of beef? That's what they want, not x. So what do we do? To find the price of beef, we just plug in the x value into this equation, right? Do you see this? So b equals 2.35 plus 0.25 into 4, right? Remember that we all do all these computations by hand because this is a no calculator. This is the no calculator section of this. So 0.25 times 4. Okay. So I won't go into detail into this arithmetic, but if you want any help, let me know later on with this. I can do a separate video, we can discuss later. So we have 2.35 and 0.25 times 4 is just 1.1. Let's say 1.00. This end up having to be, so 2.35 plus 1.00 is just 3.35. So this is your answer. So you get D as your answer, right? Yes, this question is really, I would say, a little bit heavy on the amount of uh, content that is tested. They are testing your ability to solve equations as well as to deal with this, uh, decimal fractional values. So yeah, let me. So I have seen a lot of students actually struggling with these types of fractions. Let's do some examples again and then we can see how it goes, right? Just a few examples of those types. So example, let's say we want to compute point 16 over 0.04, right? Okay, so you do the same thing. So this decimal point is over here. We can actually move it over here. We can get 1.6, or even better, we can move it over here. So that ends up being 16. Okay, and we do the same thing with this. So we need to jump twice over here. So that gives you 4, right? Because this is just 0, 4, and 0, 4 is just 4, right? And so this turns out to be 4. It's not that hard, right? Okay, remember that we can do this only when you have, this terminating decimal points. For example, let's say you have something like this, point 33333 all the way, right? And then you have something like point 2 or something, whatever. You can't do this because you move the decimal point here, it never ends. You have another decimal remaining around. So I'm just recommending this when you have this terminating decimal decimal numbers where you by you don't have any digits. I mean the numbers stop after a while, right? Okay, let's do this example. um point um 5 and 0.25. Okay, so over here you may be tempted to do, okay, this one once this, okay, so we get 5, but you did only one jump. So over here also we will have to do only one jump, so we end up having 2.5, right? But this is not, I mean, you see that you still have a decimal number down there, right? So what I would recommend is always look at the two numbers and see which number has the most number of decimal points. I mean numbers after the decimal point. And then act according to that maximum number. For example, here you have 2 and 5, two numbers. Here you just only have 0.5, right? So what you can do is basically use the bottom number. You have to do two jumps, 1 and 2. So you end up having 25 down here. And over here you also need to do two jumps, 1 and 2. So remember that you will always have a 0 over here, right? So I mean, what I'm saying is that um, 0.5 also is the same thing as 0.50, meaning that when you do two jumps, you end up having 50, 0 at the end. Okay, now you know what you need to do, right? 50 over 25, which is 2. So that's how you deal with these types of numbers. So don't freak out when you see things like this, especially in the no calculator section. There's easy ways of dealing with these types of computations, right? All right. Okay. So let's move on to the next question. So now I will be moving on to the ninth question of the section 3. I just wanted to move 9 in advance of question number 11 because the next I wanted to deal with these types of equations with systems of equations. We have two equations later on after dealing with equations with just one I mean simple equations that you only have one variable, which is x or len, right? Okay, so this one, so there's two ways to deal with this. One is the method of elimination and the other is the substitution method, right? Okay, I'll first work out the elimination method. Right. Okay, so the elimination method goes as this. So you have two uh, equations. First thing that you need to do is you see that you have x and y, 3x plus 4y. Now we have 2y minus x. I would like to change the order of the variables in the second equation, so I can actually have x's first. So the first equation is 3x plus 4y equals negative 23, and over here you have, when you just change the order of this, you have negative x plus 2y equals negative. Remember that we haven't done anything, any change. Effectively we haven't done any change to the equations. What we have just done is just change the order in which you have the variables in the second equation. Okay, now what we want to do in the method of elimination is that we want to somehow cancel out, remove one variable from the equations, right? Okay, so I will choose to remove the variable x from this. So what I'm going to do is I'm going to add the two equations so that I can remove this variable. So Okay, I'll show you the process, and we can understand why I did that, and then we will just go back and analyze the method that we just did now, right? Okay, so what I'm going to do is I'm just going to take this equation and multiply by 3. So this gives you, so if you multiply the entire equation by 3, what happens? Negative x times 3 is going to be negative 3x. 3 times 2y is going to be 6y. And when you multiply negative 19 by 3, you end up having negative 57. And now you are going to have to add this equation and this equation. How do you add them? So you have 3x plus 4y, which is one of the original equations, the first equation, and then you add the other equation that we obtained by multiplying by 3, which is negative 3x plus 6y equals negative 57, right? All right. So now you add this. So the like terms, where the x terms, 3x plus negative 3x, they cancel out. 3 and negative 3, they cancel out, right? So that just turns out to be 0. Plus 4y plus 6y, this gives you 10y. Let's see what we get here. This is going to end up as negative 80. So we have 10y equals negative 80. So you know what to do next. You divide both sides by 10. We get y equals negative 8. Right? Alright. Now what do? We found y. How do we find x? So in the interest of this exam, once you find y equals negative 8, you are already done, because there's only one answer with y equal to negative 8. So this should be it, right? But for the sake of completeness, since you're learning this, not, I mean, uh, my purpose is not just to do the exam questions, but to give you an understanding of how things do, because there's a written section without the with answers without given. We will do one after this. There you don't have answers given. So suppose you were given this exact question in the written section, you won't know the exact answer until you find x also, right? So it's in the best interest to do continue with the question. So how do you find x? So we can look at one of these original equations, right? For example, let's pick the second equation. So we know that negative x plus 2y equals negative 19, right? But at the same time, we know that y is equal to negative 8. So you just plug that in. X plus 2 times negative 8 equals negative 19. Negative, oh sorry, this should have been, sorry, I don't know why I wrote this is just x here, it won't change, sorry for that. So negative x, and this turns out to be negative 16 equals negative 19. So you can solve this simple equation, right? So you just add 16 to both sides, you get negative x equals negative 3. So you can cancel out the negative from both sides, you get x equals 3. You see, you got the answer that we were looking for, right? So that's one way you can do this. Okay, now for the substitution method. So how do we do this? So substitution, right? So we have these two equations, which is 3x plus 4y equals negative 23, and then we have 2y minus x equals negative 90. So here what we are going to do is we are going to write one variable in terms of the other, right? So what variable should we choose? So we have x and y, what equation should we use? So x here has just negative x. So I would choose the variable which has the smallest coefficient. That makes things easier. It doesn't make anything different. So how do we do that? So we can just subtract both sides by 2y. So you get negative x equals negative 19 minus 2y, and we just want x, so you remove the negatives from both sides, you get x equals 19 plus 2y. Okay, we know that x is equal to 19 plus 2y. So now what we do is we just go ahead and substitute it over here. That's why we call this the substitution method. Oh, wait a minute. So we're going to go and substitute it over here, right? Okay, 3 times, so instead of x, we will write 9 plus 2y plus 4y equals negative 23. Alright, now we distribute. 3 times 9, 27. 3 times 2y is 6y. And then we have 4y equals to negative 20. So we just distribute. Okay, so what do we have? So we have 27 plus 10y equals negative 23, right? Okay, so now we just subtract both sides by 27. We end up having 10y equals negative 23 minus 27. So this takes 10y equals with what? So this is just, I think this should be, oh wait a minute, I just did something wrong. So this should have been, yeah, 27. Oh, 19. This is 19 over here. Sorry, this should have been 57 here. This is 57 again, right? So this should have been 57. Sorry, just going back. So I just rewrote this. I wrote this with an error. This should have been 19, not 9. And so when you multiply, you get 57, 57, and you subtract 57 both from both sides. So you end up having negative 80. And what you do next is just divide both sides by 10. So you end up having y equals negative 8, the same answer we got earlier. Alright, so how do you find x? So this is the equation, right? So sub y equals negative 8 here. X equals 19 plus 2 times negative 8. So this is x equals 19 minus 16, and this gives you 3, the same answer that we got earlier with the elimination. Okay, so just going back to the elimination method, I don't know, you can do whatever method that is easier for you, but one thing I wanted to say about the elimination method, just to make sure why we multiplied this by 3, is that we have this 3x over here and we have a negative x here. So if you want to cancel this out, as you see, so we can just multiply this by 3 so that 3x and negative 3x cancels out. So that's how I chose to multiply by 3, right? So just to make things clear, I'm just backtracking everything. Okay, right, so this is the elimination method, and then we did the substitution method down here, right? Okay, let's move on. So this is the other equation. So this is in the written section, not in the multiple choice section. So as I said earlier, it could be the case that you can get these types of questions in the written section. All right, so let's do the elimination method here, right? So you have x plus y equals negative 9 plus, and then you have x plus 2y equals negative 25, right? Okay, so somehow you need to actually cancel some variable out. So what I would do is, so when you, I would like to multiply the second equation by negative 1. So that way I get a negative x here. So when I add these two equations, x and negative x cancels out. So what I do is I just multiply by negative 1. Okay, this is negative x, negative 2y equals 25. So now I'm going to add these two numbers together. Sorry, the equations together. And so I get x plus y equals negative 9. And this is, so I'm going to add negative x, negative 2y equals 25. Alright. So as we have conspired, x and negative x cancels out 0, y plus negative 2y, this turns into negative y. Negative 9 plus 25 turns out to be 60. So which means negative y is equal to negative 16, sorry, positive 16. And so to remove the negative sign on the y, just move the negative sign to the other side. You multiply both sides by negative 1. So I just did negative 1. So this gives you y equals negative 16. Alright, so we know that y is negative 16. Maybe we can use one of these equations, maybe this one, to find x. So we have x plus y equals negative 9. We know that y is negative 16. So we have negative 9. So this is just from this. And you add 16 to both sides, x equals negative 9 plus 16. And so it turns out that x is equal to 7, right? So the answer is 7 and negative 16. Okay, so they wanted to find the value of x, so we have x equals 7. Alright, alright. Let's see if we can do the substitution method here so that you get an idea. Substitution method 2. Alright, we have x plus negative 9, x plus y equals negative 9, and x plus 2y, I believe, let me check again, equals negative 25, right? Alright, so so you need to find one of the variables. So let's find x. So using this equation, find x. So you just move the y to the other side, you get x equals negative 9 negative y, and then you substitute it over here, actually here. So this will give you negative 9 minus y plus 2y equals negative 25, right? So we have negative 9, negative y plus 2y is positive y, and this is negative 25. Okay, y, so you add 9 to both sides, you have negative 9 minus 25, which gives you negative 60. And then you substitute this here, which gives you x equals negative 9 negative negative 60, right? To be careful with the double negatives. Negative 9, this gives you positive 60. So 16 minus 9 is just 7. The same answer that we got earlier, right? So x equals 7. Alright, so I think this is all for today, and hope to meet you in another video. See you.